Good morning. Today we're working on Geometry Lesson 6.1, which is classifying triangles and determining their properties. So you're going to be able to recognize and classify triangles and use the measure of one or two angles in a triangle to predict the measures of the remaining angles in a triangle. The first part of this lesson is going to really cover classification of angles and angle parts, because although you may have learned this in the past, you're probably rusty at it. And then this is supporting lesson skills F1, F2, F3, and F4. You must take notes on this as usual, and you're going to upload them to either the Student View Dropbox or you're going to send them to me by email. And no later than this Saturday at 11:59 p.m. Do not forget the header. You must have this header in to get full credit. Okay? All right. Let's do a little triangle classification. So triangles are classified by their angles and by their sides. So the first section here is a classification by side. So you see three triangles. The first one's an equilateral triangle. It has three congruent sides. Okay, that's this one, and you see the tick marks. The second one is the isosceles triangle, which is similar to an equilateral triangle, but instead it has to have two congruent sides. The third side is called the base. And then you have a scalene triangle, and it has no congruent sides at all. Okay. Now, when we classify by angles, we are kind of repeating what we do up here, but we're just classifying by angles. So here's an acute triangle. It has three acute angles. And remember, an acute angle is less than 90 degrees. So it's less than 90 degrees. Then we have equiangular triangles. They have three angles that are congruent. Okay. Then you have right triangles, and it has one right angle, and of course that's 90 degrees. And then you have obtuse triangles that have an angle that is greater than 90 degrees, which is what this angle is here. Okay. And there's a little note down here that an equiangular triangle is also an acute triangle. So you'll notice these are both really acute triangles, and they're equiangular. Right. So this is the definition of a triangle, basically. Triangle is a figure formed by three segments joining three non-collinear points. So if you aren't sure what it is, this is it. Make sure that everything you do involving triangles has this in the back of your mind. A triangle can be classified by its sides and by its angles. Okay, we said that before. So this triangle ABC below has three acute angles and no acute congruent sides. And you'll notice the angles each have a different measure. And so this is an acute scalene triangle. Triangle DEF here has one obtuse angle. Remember, that's greater than 90 degrees. And two congruent sides. And then, of course, the third side is its base. Okay? So this just happens to be an isosceles triangle that has an acute angle in it. Right? And a subvariation of a triangle. All right, so let's look at basic triangle parts. Vertex. Each of the 3 points joining the 3 sides of triangle ABC below is called a vertex. And the plural of vertex is vertices. Okay? So then the next thing you want to know is about adjacent sides. So in a triangle, 2 sides sharing a common vertex. So I've got 2 sides here, angles are sides AC and AB. They share a common vertex, which is vertex A. And so they're adjacent sides. The third side, BC, which is opposite angle A, is called the opposite side. Pretty simple to figure, but when you're talking about where something is, it's nice to be able to give a location with greater particularity. All right, now we're going to look at right and isosceles triangles. So the sides of a right triangle and an isosceles triangle have special names. That's why we're looking at them here. So in a right triangle, the sides that form the right angle are the legs of the triangle. So here you see the legs. And you'll notice they form the right angle, the 90-degree angle here. Right? This is the 90-degree right angle. The sides opposite the right angle, so that's what the arrow is pointing towards, from the right angle to this other side, that's the hypotenuse. Okay. Now over here on an isosceles triangle, the triangles have, an isosceles triangle, you should know, can have three congruent sides, in which you would call it an equilateral triangle. So share common characteristics here, and that's the only reason why we point that out. So when an isosceles triangle has only two congruent sides, then these two sides are called the legs. And the third side, opposite the angle that joins the two legs together, is the base. Okay? All right. Now let's look at parts of isosceles right triangles. So this is a right triangle that happens to have two legs that are congruent. So the hypotenuse of all right triangles, again, is the side opposite the right angle. So there you show that there. And in this case, the hypotenuse is also the base, because with isosceles triangles, we call that side opposite the angle that is formed when the two legs are joined to get the vertex here, in this case C. That angle is opposite the base. Or if it's a right triangle, it's opposite the hypotenuse. And if it's an hypotenuse right triangle, you can use both names. Either or both. Okay. Now, let's look at interior and exterior triangles. So, I'm sorry, exterior and interior angles of triangles. So if you extend the sides of a triangle, like I've got in this first picture here on the left, the three original angles, A, B, and C, are considered interior angles. In other words, they're right in here. Okay? They're right in here. They're these angles. The angles that are adjacent to and on the outside of the triangle are the exterior angles. So you see there are angles that are formed in these three areas. Okay? And they're called the exterior angles. And each vertex has a pair of congruent exterior angles. So I identified them here. Vertex A, you'll notice, is an intersection. So these are vertical angles. A and the angle across from it, and the exterior angle A, I should say. So these two. And B, same thing. You have two congruent angles because they are vertical angles. And C, the same thing. Okay. When you are looking at exterior angles, it is common to only show one exterior angle at each vertex. So this is what you usually see, this picture here. They didn't have these extra little extensions that came out, you know, here, here, and here. And so these shaded areas here, again, are the exterior angles, okay, that you normally talk about. Okay, so when measuring the angles of triangles, ancient philosophers discovered that if a geometric figure is a triangle, then the measures of an exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. So I've got a picture of this right here. Here's a triangle, and there's an extension here, and there's an exterior angle that they call angle 1. And so they say that the measure of angle 1 here is equal to the measure of angle A plus the measure of angle B. Okay, so you add those together, they equal this. And this is what we call the exterior angle theorem. So we're going to be using that in just a little bit. Now the other thing we want to know is, you know, what proves that we've got 180 degrees inside a triangle. I'm sure you've heard that said. So, well, the ancients discovered that if a geometric figure is a triangle, then its interior angles measured 180 degrees. So this angle plus this angle plus this angle inside here always equal 180 degrees, no matter what the different measures of those angles are. When you add them together, they equal 180 degrees. And this became the triangle sum theorem. Now, how did they prove it? Well, they proved it by observation. And it is now a theorem because somebody wrote it down, and this writes down the proof of it, and so this is what creates it. So we're going to prove here. This is done as a statement, reason, proof, and I'm going to just do this. So given you've got a triangle ABC, we want to prove that the measure of angles 1, 2, and 3 equals 180 degrees. So here's angle 1, angle 2, and angle 3. All right. Now, what we're going to do is we want to prove that these angles equal 180 degrees. So this picture has been changed somewhat. We don't just have the triangle, we have this line BD. And BD is parallel to AC. AC is the base of the triangle, and BD is just added on the top. And those are two parallel lines. See these little arrows? They tell you they're parallel lines. Okay? So those are both given to you. Now, it just so happens that, that when you draw these, this is basically the basis of the parallel postulate. So I just added that to it. All right. Now, let me see here. So what we got going here, if you look at this picture, you'll notice that angle 4 and angle 2 and angle 5, if you were to note, they all share a vertex at B, and that if you add them up, they all form basically three angles that are 180 degrees. How do we know this? Well, these are called straight angles. So we can say that the measure of angle 4 and angle 2 and angle 5 are 180 degrees because they're straight angles. We can also say that because the angle addition postulate allows us to add together the three angles. So I wrote down here angle addition postulate and definition of straight angle. Okay. All right. Now, if you'll notice, if you look at this, you also have angles 1 and angles 3 that we need to deal with. Angle 2 is up here. It's part of this group, but it's still inside the triangle. We want to prove that these three angles, 1, 2, and 3, are 180 degrees. We know about angle 2 as being part of that group, but it's also part of this group up here, 4, 2, and 5, which equal 180 degrees. So what can we do? Well, we know we have these two parallel lines, BD and AC. And if you look at line segment AB, it is what we call a transversal. It connects these two parallel lines. So whenever you have a transversal that's connecting two parallel lines, then angles formed on the opposite sides of the transversal are considered congruent. And since these are on the inside, these are alternate interior angles. So angle 4 and angle 1 are congruent. Similarly, if we look at line segment BC, it connects the two parallel lines BD and AC. So it's a transversal, BC is a transversal, and so the two angles that are on the opposite sides of the transversal BC, which are angles 5 and angle 3, are also alternate interior angles and have to be congruent. So we can say that the measure of angle 1 here is congruent to the measure of angle 4. So I wrote that. And the measure of angle 3 is congruent to angle 5. And we said alternate interior angles. Okay, so the alternate interior angles theorem is the is what shows congruency, proves congruency. So it's the reason. Now, we want the measure of the three angles. Remember, measure, and we're adding up here. This is actually algebra up here, regular math. It's not geometry. So we have to switch this congruency. See, these are all congruent angles. We want to get their angle measure. So we rewrite this as the measure of angle 1 equals the measure of angle 4, because that's true, because if you have congruent angles, then their measures are the same. So the measure of angle 1 has to equal the measure of angle 4. And since angle 3 is congruent to angle 5, the measure of angle 3 has to equal the measure of angle 5. So that's the definition of congruent angles. Okay? All right, so then let's go on. Well, we're really to the end of this, because if we proved that angle 4 and angle 3 are the same, and angle 5 and angle, I should say the measures of angle 4, let me restate that. The measure of angle 4 and the measure of angle 1 are the same. They equal each other. And the measure of angle 5 and the measure of angle 3 is the same. I could take this angle 1, I could put it up here. And I could take the angle 3 and I could put it up here. And I could say measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees, just by using substitution. And that's in fact what exactly we're doing here. So we're substituting, measure of angle 1 for 4, and the measure of angle 3 for 5, and we already know what the measure of angle 2 is part of what's in the triangle, and so we know that it must equal 180 degrees. We've got it. We've just proved it by substitution. Okay, so that's how the ancients figured it out. All right. So now what we want to do is we want to look at exterior angles. So how do we determine the measure of an exterior angle? This is our second example. And so, you know, you can apply the exterior angle theorem to find the measure of the exterior angle. And so in this case, the exterior angle measure is written as an algebraic expression. Here's the exterior angle. It's 2x plus 10 degrees. And then the two interior angles that are opposite this exterior angle, remember they, according to the exterior angle theorem, equal the measure of the exterior angle. So you just add those two together and they equal this exterior angle. So we rewrite this as x plus 65, or x degrees plus 65 degrees equals 2x plus 10 degrees. Okay? So now all we really need to do is the algebra. Let's drop these two, or the parentheses, because frankly there's no reason to have them on there. And so let's just rewrite this as x degrees plus 65 degrees equals 2x plus 10. And they're all degrees. That's the only reason why the parentheses was on there. In fact, let's just get rid of the degrees altogether. Let's get rid of it, so we don't have to see it there, right? So, in fact, let's just do this real fast. Put a little eraser here on it. Okay. All right. So x plus 65 equals 2x plus 10. So we drop the degrees. Now what we want to do is we want to get the x's together. So we're going to subtract. So we're going to use the subtraction proper quality. So that means we're going to subtract x from both sides. And so when we do that, we get this canceling over here. We get 65 equals 2x plus 10. All right. Now, we want to get the x by itself, so we have to subtract 10 from both sides. So we're going to do the same thing again. We're going to use the subtraction property of equality. And I'm using these little hash marks to show that we're repeating this. So I'm going to subtract 10. Well, let's use, I'm going to subtract 10 from both sides. And when we get 55 degrees, oh, we forgot to subtract the rest of the x. So when we subtract x from both sides, of course, what happens there? In the previous one, we get x. So let's use my little whiteout again. Pay attention to what I'm doing. So we have x plus 10. 65 is x plus 10. And so we subtract now 10 from both sides, and so we end up with 55 equals x. Right? So now we've solved, and since we know we're dealing with degrees, x degrees equals 55 degrees. Okay? So we've got that taken care of. Now, 2x plus 10 equals the exterior angle. That's the exterior angle. And why don't we say the measure of? So the measure of, I'm going to write this out, abbreviate. The measure of 2x plus 10 equals the measure of the exterior angle. All right. So now we're going to substitute. In this case, we're going to substitute 55 for x. So I'm going to have 2 times 55. And that is plus 10. And that equals the exterior angle. I'm going to abbreviate, all right, or the measure of the exterior angle. So what's 2 times 55? It's 110. Plus 10 equals the measure of the exterior angle. So this is what we do here. We multiplied or distributed. We'll say multiplied because it's simpler. So that's the multiplication property of equality. These were all properties of equality: subtraction property of equality, substitution property of equality, multiplication property of equality. All right, and so then the last thing we're going to do is add. So addition property of equality. So 110 plus 10 is 120 equals the measure of the exterior angle. Okay, so 120 degrees equals the measure of the exterior angle, and so we found it by first solving for x. So this is several steps that we go to do this, but you can see that it's easily done with some algebra and some common sense. All right, so now we go to the last thing that we're going to do, and so here we're going to look at a shortcut for finding the measure of an interior angle of a right triangle. So when you have a right triangle, you already know that the right angle here has a measure of 90 degrees. So this is 90 degrees. Let's use the red. It's hard to see, but there it is, 90 degrees. And therefore, you can apply a corollary to the triangle's sum to help you find the measure of the remaining two angles. Corollary is just kind of a sub rule that is, in this case, it's sub to the triangle sum theorem, and that is that the acute angles of a right triangle are complementary. In other words, look, if the whole thing equals 180 degrees, if all three interior angles equal 180 degrees, and you already know that one of them is 90 degrees, then the other two angles have to equal 90 degrees also. That's why they say complementary. All right? So in the below right triangle, the measure of one acute angle here is 2 times the measure of the other acute angles. So what I did was I let the measure of angle A equal x degrees and the measure of angle B equal 2x degrees. And we know that those two angles equal 90 degrees. So since we know that, we can go ahead and write this out. So let's just let's substitute now x for the measure of angle A and 2x for the measure of angle B. All right, so this is substitution property. I'm going to abbreviate property of equality. And so this is x plus 2x equals 90 degrees. All right, so now what do? We simplify by adding. So simplify, and this is addition property of equality. All right, so x plus 2x is 3x. So 3x equals 90 degrees. All right, so now we use the division property of equality. I'm going to simplify, or I'm going to abbreviate again, division property of equality. And so that I'm going to divide by 3, and that means I've got x equals 30 degrees. All right? And so now that I know that, then I know that 2x, substituting, 2x equals the measure of angle B, right? So measure of angle B, so that means 2 times 30 equals the measure of angle B. And so that means 60 is the measure of angle B. Up here I said x equals 30, but also x equals the measure of angle A. So measure of angle A is also 30 degrees. Okay, so measure of angle A is 30 degrees, measure of angle B is 60 degrees, and there you have it. Okay, so we are done with this, and I'm going to let you go. I hope you have a wonderful day, and I hope you have a wonderful Thanksgiving. Thank you. Bye-bye now.